Problem 7. The 1.2 meter diameter lug of specific gravity point 8 shown is 3 meters long into the screen and blocks water as shown. Compute the net vertical and horizontal reactions at point C. So this is the given figure. For the horizontal, we have going to the right and going to the left. So call that FH1, FH2. We anticipate that FH1 is greater than FH2 because of the greater depth. Therefore, the horizontal reaction at C should be to the left. I'll call that CH. So FH1 is specific weight of water. Let's express the answer in newtons. 9,810. Bard H is zero point 0.6, half of 1.2, because this is 1.2. Area is 3 meters by 1.2. So FH1 is 9,000. FH1 plus FH summation versus horizontal. FH1 equals CH plus FH2. So let's use that as our working equation to solve for CH. Where FH1 is 9,810, Bard H is zero point 0.6, area 3 times 1.2. Equal CH, if H2 is 9,810, Bard H is zero point 0.3, half of 0.6, area is 3 times 0.6, the depth is 0.6, so area is 3 times 0.6. Solving for CH is 15,892 newtons and it is leftward. For the vertical component or reaction at C, first let's have FV1. For this curve here, left half curve, supposedly we draw vertical lines through the endpoints of the curve in contact with the water. So this is the endpoint, the other endpoint is on top. So supposedly we draw vertical lines up to the liquid surface. But since this is already the water surface, so the top point is fixed. At the bottom point C, we draw vertical line up to the liquid surface. So therefore, the volume to be considered in computing FV1 is this half circle, then times 3 meters long. So that's FV1, specific weight of water times volume of half circle with length 3 meters. For FV2, we draw, these are the contact points, C and this point here. Supposedly we draw vertical line, but since this is already the water surface, we stop there. For C, we draw vertical line up to the center because this is the water level for the right part. Then the volume to be considered would be the volume bounded by the curve, this imaginary water surface, and this vertical line here. So it is a quarter circle wedge. So therefore that's FV2. Then the weight acts downward, and let's assume that the vertical reaction at C is upward. So summation forces vertical equals 0. C sub V plus FV1 plus FV2 equals W. FV1 is equal to specific weight of water, and volume is pi over 2 or 0.5 pi of radius square, 0.6 square, times length perpendicular to the board, 3 meters, or area of semicircle times 3. That's the volume to be considered. So FV1 is equal to 16,642 newtons. FV2 is expected to be half of this. So FV2 is 9810.25 pi or pi over 4 radius square times 3. So FV2 is equal to 8321 newtons. As I said, half of that. Then the weight is specific weight of the lug, which is 0.8 times 9,810. Volume of the lug circular is pi radius square times 3. So 0.8 times 9,810 times pi, 0.6 square times 3. So the weight of the lug is 26,628 newtons. Substitute in this equation here, C sub V plus 16,642 plus 8,321 equals 26,628. Solving for C sub V is 1,665 newtons upward because it is positive.